I realized during the last class, I forgot to tell the winner that they won. All right, so during class, I am going to pick a winner for so as we are working through. So do make sure that, just as a fun thing, because that's our last session, we do have a party. Can you guys write this date down? We have a party coming up, and it is right here. I have a party on December 14th, which is a Thursday at 4 p.m. Pacific. Go ahead and write that down if you'd like to join me. We are going to do a full review. I know originally I said, let's just do weeks 5, 6, and 7, but it's hard to do that without doing weeks 1 through 4. So I just finished putting the review together. It's a fun party. We're going to have some fun doing it, and you do need a handout, and I'm sending that to you as well. Okay, so if you'd like to join us, this is great. There is no, it's not recorded or anything. So, all right, but as a way to celebrate today, go ahead and type in your answers as they come to you, and then ask a lot of questions as we go. We are going to be looking at quadratics, no new content from last week. So we are just gonna practice what we know and get really, really good at it. Doug does have a session, good question. Doug has a session, and one of the streams just crashed. Hang on a second. He has a session on Thursday at your regular time. There it is. Okay. Looks like all of our streams are good. We have kids, and we have a teacher, and we have math. I think this is all we need. Shall we begin? We had a party last night. Can I tell you about that? That was super fun. When one of the things was actually I put all these geometry shapes into a bag, and the people had to put their hands in without looking and pull it out, and then try to pull out the right piece from the bingo sheet and pull out the right one. And it was really funny. Like the kids were totally into it, and there were a couple of grown-ups, but most of the grown-ups were like, I don't think I want to do this one. It's like too hard. And the kids were like, no, this is easy. This is so much fun. So it was really cool. We had like 18 different games that I put together. So anyway, this is something we're going to get to at one point. All right, let us get started with our session. So yay. Okay, I cannot believe it has been such a fun session so far. We have my notes, and we are ready to go. All right. So we are in Algebra session number 7. Grab your math journal. And if there is something in particular that you'd like me to go over in more detail, you can put it in the chat. I am taking requests. But we are going to be studying quadratics. So as I had mentioned before, when we study math and engineering courses, and we spend a lot of our time in physics and a lot of our time looking at forces, looking at energy, looking at the motion of things, rocket ships, cars moving, you name it, buildings being built, stresses and strains, and from things being loaded to make sure they don't break too soon. So one of the things that we do is we're trying to solve for something. So we'll put the real world on paper, and then in college, the professors will say, okay, and now I want you just to solve for this because you already know how to do the math part. So they won't actually go over this step that I'm doing with you, which is why we learn it first. And then you learn the more complex, like how do you get these equations in the first place? So for example, when I write this equation down, you may think, now come on, Aurora, where am I ever going to see? This is not going to be walking down the street, right? I'm not going to see this. Okay, so where this comes from, it is science. This is where this stuff comes from. We are taking the real world, modeling it, putting it on paper. This X might be a fuel rate. This X could be force. This X could be acceleration. So we don't know where the thing came from at this point. So that's why we do a lot of the labs afterwards. So once you get good at this, then I say, hey, now watch me do an actual problem. And then I might be describing like the orbit of Mercury or something, or maybe a satellite that's trying to land on something that moves like a comet. And then we're going to have things like this, and I'll say, okay, now how do we solve it? So that bridge is something that we're also starting to build. Okay, but for this class, we're just going to get good at how to solve quadratic equations. So notice that we have an x squared, we have an exponent. This one doesn't have an exponent, but there's a little hidden 1 there. If there's no exponent, it's always going to be a 1. This one, how do I want to write this? Okay. Do you remember when I said, so if I said this is just 5 by itself, and this is kind of a little aside, 5 squared is 5 times 5. Do you remember that? And 5 cubed is whatever that is, so that times itself 3 times. Remember this for exponents? If one of them, if that exponent is a 0, doesn't matter what the value of this thing is, it's always going to be 1. Okay, it's always going to be 1. Which means x to the 0 is always has a value of 1. So one of the things that we look for in our polynomials, okay, is consistency. So look at this. I have a coefficient, which is 3, and then we have an x squared minus 5. I'm going to put the exponent in so you can see it. Okay, so that's a 2, a 1, and then watch this. A 2, 1, and a 0. You see that? Okay, so because this is x squared, we put it there. X to the first, we just drop that. X to the 0, this is a value of 1. 2 times 1 is always the value, whatever it is. 2 times 1 is 2. All right, so there is an x to the 0 power here, but we just don't write it. But I just wanted to show you that we write them all in descending order when we write our polynomials. Okay, that was kind of like a little aside, just a quick little aside. Okay, so how do we solve this one? So this one we cannot solve by factoring. All those great methods we learned back in session number 6, none of them are going to work. Okay, so let's use our sledgehammer, known as the quadratic equation. So let's find our A, B, and C. A is whatever's in front of the x. So I'll write that in a different color. A is 3. B is minus 5. C is positive 2. So you have to take the sign in front of everything. Okay? So don't forget that part. That's a plus. All right, the quadratic equation, so you can write it down so you have it for yourself, is x equals. So we're solving this thing for x. All right, it's going to be negative b plus or minus the square root of b squared minus 4ac all over 2a. I know it took us a long time to get to this point, didn't it? Can you see how if I had just given you this initially, you might have just freaked out and gone, I have no idea what that is. So it takes us a long time to figure out how to use this thing, right? Because of the square roots and everything. Okay, let's bring it a little bit closer. Okay. All right, so what we're going to do is we are going to say, every time there's a B, I'm going to put a minus 5. Every time there's a C, I'm going to put a 2. Okay, so let's rewrite it. So x equals negative b, so negative and then negative 5. So this is the first place people make mistakes. They'll just write negative 5 because they see the negative and they're like, oh yeah, it's negative 5. But do you see how it's going to become a positive? So here's mistake number 1 that gets made. Plus or minus, make sure you put that in there. Square root, all right, negative 5 squared. Just copy it down. Don't do any calculations in your head. Just write everything down. Because this thing is so complex and big, it's easy to make mistakes. So just copy down everything that you see. Just copy, copy. Okay. Okay. All right, what do we do next? Are you guys already reducing it? I'm seeing some people are still writing. Okay. So what's the first thing we want to do? Well, we're going to push this up so we have more room. Okay. So the first thing I want to do is anything in parentheses, that's too much room. Anything in parentheses, let's take care of. So x equals negative 5. I'm going to turn that into a positive 5 plus or minus square root of negative 5 times negative 5. I can just put that down as a 25. I'm going to put the negative here. 4 times 3 is 12. 12 times 2 is 24. All over 2 times 3, which is 6. Whoops, so I made that way too big. There we go. Boy, that looks a lot nicer, doesn't it? And look at this. X is equal to 5 plus or minus, this is a square root of 1 over 6. Square root of 1 is really nice. It's always 1. Okay, so this means x equals, take the top one, so 5 plus the square root of 1 is 1, 5 plus 1 over 6, and x equals 5, now take the lower one, minus 1 over 6. This is 6 over 6, which is 1. This is 4 over 6, which is 2/3. Okay, good. All right, how are we doing so far? Doing good so far? Okay. So what do we do with that? Okay, so these are the roots. Okay, remember, because there's an x squared, that means we're going to get at most 2. Maybe you'll get 0 if there's no real roots. If you have like a -1 in here, you'll know that this blew up, and so you can't do it. You'll say no real roots. Okay, this one has 2. And sometimes you'll get the root is exactly the same. You'll get 1 and 1 or something. So that means there's only one real root. Okay, so x equals 1, 2/3. So this is one answer. Okay, I want to be able to draw this thing. Okay, so the roots are here. Okay, now it's a parabola, so when we graph this, it's going to be like this shape. Okay, so I want to know, where does it hit the y-axis? So if this is the y-axis and this is the x, where does it hit the y? We just found where it hit the x right there and there. Okay, so at 2/3 and at 1. Now I want to find, where does it hit the y? You do that by going back to the problem, and wherever there's an x, you put a 0. So can you do this calculation in your head? 3 times 0 minus 5 times 0, that's still 0. Y is equal to 2. Exactly. So that's where it hits. Perfect. Good. Okay, so the y-intercept is going to be, you can write it as a coordinate, like that. Okay, so it's 0, 2. We're almost there. The last thing I want to know is, where's the vertex? Where is the lowest? We call this the minimum. All right, and I'm going to give you a formula for it. When you get to calculus, where the formula came from will totally make sense. But don't worry about it. Just use the formula for now, okay? Because where it came from is not important yet. The fact that you can use it. It's kind of like electricity. A lot of people don't know how it works, but they know when they flip a switch, it works. It lights up the room. Okay, that's an A. That looks like a 9, doesn't it? Again. There we go. It's an A. Okay. So you just go back up to your problem and you say, okay, negative b, so minus 5, yet another place to drop a minus sign, so be careful, don't drop anything. 2 times 3. Okay. So this is a positive 5 over a 6. Okay, so this is the x coordinate. To get the y coordinate, you stick this in here and you get y, because we only have one unknown. Okay, so I'll rewrite the problem. So if we do it like this, then you can see everything. Okay, sort of. Y equals 3 times 5 over 6 squared minus 5 times 5 over 6 plus 2. Good. I love it. I love seeing you guys take notes. This is great. Okay. So I just, wherever there was this x, I put it in here. Okay. Because anything you put for x, then you get a y. You know, you can put 0, 1, 2, and that's actually how you get the parabola shape, right? That's how we figured out that that's the shape of the thing. Okay. All right. So let's go back up here. Let's do our math. This should be, you guys could probably beat me to this answer. 3 times 25 over 36, that looks ugly, minus 25 over 6 plus 2. All right, this is going to be a 12. What else can we do here? I think that's it. So y is equal to, I'm going to keep this here, 25 over 12. I'm going to scale this one up, minus 25 times 2. Over 6 times 2, which is 12, plus 2. So I'm just scaling up the fraction. Okay? And then you add everything up. This is going to be 12. This is 25 over 12. This is 1 minus 2 plus 2. Just writing it in a way I can do. So this is minus. Okay, so this is a y is equal to, so this is a minus 1. Minus 25 over 12, which is 2 and a 12th, plus 2. So this is minus a 12th. So that coordinate was a little messy, wasn't it? So the vertex is the x value, which was 5, 6, which we got up here, 5, 6. And then after we plug this into the original equation, it spit this thing out, minus 1/12. Okay, and that's where the minimum happens. Okay, you have everything you need to plot it. Okay, so let's take a look. How do we plot this thing? Okay, so what we would do is we would draw like this, x and y. Okay, my roots are 1 comma and 2/3. My vertex is 5, 6 and minus 1/12. And my y-intercept is 0, comma 2. The other thing you need to know is if a is positive or negative. Which one do you think it is here? Yeah, it's positive. Because it's positive, it opens up. If this was a minus 3, then it would be flipped upside down. So what I'm going to do is I'm just going to draw it like this, and then you label things. So this is my y-intercept. This is 0, comma 2. This is my root. This is the root of 2/3. This is the root of 1. So 1, and then the coordinate is 0 for y. Okay, so this is at 2/3, comma 0, and 1, comma 0. The vertex, I'll do in green, so it's a different color. Okay, the vertex is at 5, 6, comma minus 1/12. So obviously not drawn to scale, but that's okay. For these types of drawings, and you're just sketching it without grid paper, this is okay as long as you label everything so you know where it all is. And then what you can do is you can put it on a computer program, and you can just put in the original equation. Oh, I always put in the original equation. So someone else can know what is it that I'm plotting, and it's this thing. So from maybe a math or an engineering world, if this is, say, acceleration of a rocket, and I might want to know where is the rocket at time t equals 2. Okay, so maybe x is my time here, and I want to know what is it? What's the speed of the rocket? Okay, I'll be able to read it off this graph. And maybe part of this graph won't make sense, and so mathematically speaking, these do make sense for math, but in the real world, we might never have a speed of like -3. That may not make sense. It just depends on how you defined your parameters. Okay, and so on a computer program, it would look like this. Here, let's zoom in and make it focused. So notice how what the computer program does, it will convert these to decimal numbers. But if you remember 5, 6, that's right here, the vertex is 0.883. Okay, and this is 1/12. All right, so here's my 1, comma 0, and here's my 2/3, 0.666, right? And then here's my 0, comma 2. There's my intercept. We got the same thing. Yay! You should be smiling really big. This is huge. If you can do this, this is what people call algebra. They're like, yeah, I don't know about this. This is it. You did it. Yay! All right, so how are we feeling with that problem? I have more, but I want to kind of see how we're doing. Okay, more practice? You want a little more practice? Let's do more practice. Let's do ones where it's a little messier with the square root. Should we do those so you can see it? Not too messy, but messy enough. Okay, let's do a little bit messier. Good. You know what? That's a great idea. Somebody's asking, can you pick a prize during the math party? Yes. How about we do that so you guys can focus on this? Yes, yes, yes. Okay, algebra problem. Suppose my problem looks like this. Do you remember what I was saying about writing this in terms of descending order of exponents? Can you do that for me? So I want this as y equals something. Y equals something. Okay. All right, it looks like you can look up when you've got it so I can see. All right, so I have my y on the other side, and you throw these over here. So I have x squared, and I've got a plus 4x and a minus 20. Did you get all the signs right? Okay. Tell me what is A, B, and C. I'll do mine off screen, and then we'll compare. Okay, did you get it? Okay, how's that? We good so far? Remember the minus sign? Okay, here we go. X equals. All right. X equals negative b, write that down, plus or minus the square root of b squared minus 4ac. So b squared minus 4ac. And I will write the 1 in it so I know that it's in there. So I know I didn't forget and just have 2 numbers multiplied. I'm looking for 3. Okay? And same with the denominator. I know sometimes people like to do it in their head. This helps me stay organized, especially when the problems get harder. Okay? All right. Can you tell me what number is in the radical? Go ahead and simplify it. I'll do mine off screen. What number do you get in the radical? It should be positive. Yes, good question. Oh, I didn't realize you could see my writing. Oops. There. Okay. All right, did you get in, did you finish? No? Okay. All right. So the first one, 4 squared, that's your 16. Okay, and then 4 times 1 is 4. 4 times 2 is 8, and then the 10 makes it 80. So this is the square root of 96. All right, would it help you if I told you 96 is the same as 6 times 16? Do you like that? Is that better? So what are you going to do? Okay, so it's minus 4 plus or minus, well, actually, let me do this on another piece of paper. I'll put this up here. Hang on. Just ignore that. Okay. So x is minus 4. 16 is 4 times 4. So I can pull one of the 4's out. So it sits right there. But I have to leave the 6 inside because it's 2 times 3. But that 4 comes out and it goes here. It doesn't combine with this 4. It's multiplied by the radical. And that's what I have. Okay. So then that becomes, I'm going to divide everybody by 2. And this is important. If you're going to divide by 2, you got to make sure whatever's in front of the radical also has something. So this is going to be a 2 and a 2. So this is minus 2 plus or minus 2 root 6. That's what x equals. Okay? If there was nothing in front, if it was just 4 plus or minus root 6 over 2, you couldn't divide this out. It has to have something here, right? Because the 2 can't go inside. Okay? Good. I'm seeing some head nods. Good. So this is x equals minus 2 plus 2 root 6. And x equals minus 2 minus 2 root 6. Okay, so that's what this becomes if we write it out longhand. What is that? Those are the answers. So how do you graph these are the roots. How do you stick that on a piece of graph paper? Well, you get one of these handy things out. See that? Okay, so what you do is you say 6 square root, that's this, times 2 plus a 2, that's a negative. And I have a number. Here, let me just do the 2 root 6 so you can see it. So root 6, you take square root of 6, and then you multiply it by 2. So I have 4. Let's call it 4.9. Okay. And this is minus 2 minus 4.9. Okay, and this is just decimals, right? You can do this in your sleep. 2.9, and this is 6.9. Okay, so now you have the roots that you can plot 2.9 and 6.9, right? So the roots are going to be at 2.9 comma 0, right? Because that's where they hit the axis, and 6.9 comma 0. So when we sketch this, which we will do soon, the x value a is positive, so it's going to go up. So here's the 2.9, and here's the 6.9. It's right there. Somebody had said graphing is hard. Yeah, I totally understand that. The way we get good at it is just by practicing. Yeah, so this is 2.9, this is 6.9. Okay, doing good? Okay, so let's find out, can you tell me where it hits the y-axis? Where does it hit the y-axis? So if we look at our original problem, y equals 0 plus 0, yeah, it's going to hit at minus 20. So I have my, so the y-intercept is going to be 0 comma minus 20, which tells me my picture, this is going to be way down there, okay? So it's probably going to look like we get more and more clues as we go along. So my guess is if it's going to hit at minus 20, it's going to hit way down there. Okay, so let me think about how this is going to work. Hang on a second. Okay, let's do the vertex and then we'll plot everything on one graph. That's probably the easiest way. Here's the vertex. Okay. And I did something wrong. Do you see where it is? What did I do wrong? That's why I got confused. Look, I dropped a minus sign. How convenient of me. That has to be a minus. Otherwise, it's impossible for this graph to exist. This one's plus, this one's minus. So that tells me that one of these, it's like this. One of these is positive, and one of these is negative. So here's our negative 6.9 and our positive 2.9 and our negative 20. But we still have to find the vertex. Okay, so let's do it. Vertex is minus b over 2a. That's x. Okay, minus b over 2a. Okay, what was a, b, and c? So minus b is a minus 4 over 2a. Oh boy, is that easy. Somebody tell me the answer to that one. Yeah, what do you get? Minus 2? Okay. Now let's plug in minus 2 into this guy. And tell me, what do you get for y? minus 2. So I'll write it out. Here. Y is equal to minus 2 squared plus 4 times minus 2 minus 20. Can you guys beat me to the answer? If I take a long pause? Yes, I do have a funny story for today. Okay. Did you get the same thing as I did? How's that look? Okay. All right, so what are we going to do? So we have roots, the y-intercept, and the vertex. Okay, so let's put it together in a graph so you can do it with no grid paper. Okay, so what would this look like? So we'd have an x and a y. Okay, and the vertex is minus 2. Here, I'll write it so it's here. Minus 2 comma minus 24. So that's really close here, but really far down. So like here. Okay, and then the y-intercept is 0 comma minus 20. So that's just like here. Okay, and then the roots were 2.9 and 0 and minus 6.9 and 0. So those are the roots. Okay, I think I have all the information. All right, so how do we do this? So here's our vertex, and you just kind of estimate. So I have a minus 6.9, we'll call it here. 2.9, we'll call it here, not to scale. And then you draw in your parabola. So it kind of looks like that, and you put little arrows on the end. And then you say this is y equals, and then you write the original equation. X squared plus 4x minus 20. And that little squiggly arrow is probably confusing, so let's get rid of it. There. Okay. So we have the root here is 2.90 minus 6.90, so about 7. Minus 7, 0, and about 3, 0. Okay, this is minus 20. This one's minus, at this vertex, minus 24. Okay, and it's on the inside of this one, because this is 3, so this is, this one's at minus 2, or I'm sorry, positive 2 here. This is 2, and this is almost 3. This is 2.9. Good. And then the computer gave the beautiful picture. Do you want to see the beautiful picture now? All right. Nobody actually does a beautiful picture like this. This is what computers are for. And we got it. Look, here is, if I highlight the x-axis, you can see this better. Here is the x-axis. And here's the y-axis. Okay. Oh, it looks like I got it on the wrong side. Okay, so I would, oh, look at that. I put positive 2, didn't I? This was minus 2. So the vertex needs to go on the other side. So I got that wrong. So computers are great to check us on our answer. So minus 2. So even though I read it down wrong, I graphed it wrong. Read it down right, I graphed it wrong. Okay, so let me graph it right. So you have it for the recording. So to graph this, you're going to go y and x. There you go. Okay. And then our vertex was at minus 2 comma minus 24. So minus 2. We'll call that minus 24. Okay, and then that's the bottom of the graph. And then it's going to hit the y-axis here at minus 20. And then it's going to continue up. And it hits the x-axis here at 2.9. Okay, at one of the roots. And then we're going to go up. And it hits the x-axis again at minus 6.9. How's that? Does that look good? There, if you can see it, there we go. And so this is my graph. Somebody's asking, why do we bother graphing? It's because it gives us, we can get a lot of information off of this that you're going to use later when you get to calculus. Okay. So this should look like a beautiful symmetrical shape, which looks like this on the computer program. Beautiful symmetrical shape. We got the vertex, the y-intercept, and the x-intercepts, the roots. Good. Good question about what if there's x cubed. Can you hold on to that question, and then I will answer that near the end of class. I actually have a couple of graphs I want to show you. Good. All right, should we try another one? Let's try another one. Let's get good at it. Make sure you're taking a break. You guys remember to get a snack, take a bite. You want a quick story while you take a snack really quick? Okay, before we move on to the next one? All right, so let me make sure I've got the next one. Okay, so for class on, I don't even know how to describe it. Maybe this is not a good one to just. So on a chalkboard, if we want to draw things, we have like really big things like you've seen Doug, right, with the protractor and the compass. Have you seen him doing this? Okay, so it's like that. And so there are different scales for things that depending on what you do. So it's a little embarrassing. So I'm teaching a class, and I hadn't demonstrated these things, but I brought in all these tools because I knew we were going to do geometry soon. And so I'm talking to the class, and I'm like, okay, so go get your protractors, go get your compass. I'm going to show you how to use them. And so I guess a kid wanted to borrow something. And anyway, so imagine trying to use the giant compass on your page. How well does that work? And you're like, hey, hang on a minute. So you're like, So it reminds me of another story when I took my daughter for the first time. She plays the violin, and I took her for the first time to a real orchestra, like to the symphony. And so she had never seen most of those instruments, right? Because you just, you play your violin with your instructor, and that's all you really see, right? So I take her there, and so during intermission, she's so excited. She makes a beeline down and there's a few musicians, most of them are in the back room, but there's a few musicians that are just there, and they talk to people and stuff forth. And then she sees a double bass. You tell me, thinking about what I shared about tools being different scales, how big is a double bass? Have you guys ever seen these things? They're bigger than I am, right? They're enormous. They're huge. They look like giant violins. So she looks at this, and she's like, huh. And she doesn't even skip a beat. She goes, excuse me, where's the shoulder rest? And a shoulder rest on a violin, so, it's like a shoulder rest, and the chin rest is here. Like, where's the chin rest? And so she's wondering, how does he hold it? He was so patient. He's like, oh, that's a really good question, right? He's as big as the instrument, right? And she's like, I don't understand. Like, how are you going to hold it? Because it was during intermission, and she didn't, anyway. So that reminded me of scales of things, right? And you're like, no, actually. All right, cute, funny story. So shall we continue? Yes, let's go back to, I have another problem. Can you set this up and tell me what you get in the square root? Okay, I have a negative 2x squared plus a 3x plus a 9. Okay, and if I put the quadratic formula here for you, can you tell me who lives inside the square root? Oh, that's another A. My A's are looking like 9s today. There you go. Okay, so I'm going to do mine off screen, and then we'll compare. So tell me what A, B, and C are, and then just plug them in. Yeah, I really like this because it's there's like a method to it. Okay, and when you're done, look up so I know that you're ready. Zoomers, you can look up at me. So once you know who lives in the square root, if you want to pull anything out, you can, absolutely. Somebody's saying that the workbook for polynomials is not filled in. It should be. The answer key is a different file than the workbook itself. Okay, good. Yes, and I see a lot of you caught the 6.9 and the -2. Yes, you caught my errors. Thank you. I will actually make a clean recording. I'll edit that out and just put the good part in. Good. Good. Okay. All right. Do you know what lives in the square root? Good. I'm seeing that. Good, good. Can you add those two numbers together? Like actually do the addition? Okay, so here's what I have. A is -2. Just make a note to yourself that we are going to have an upside down parabola this time. Okay. Good. Did you get this mess? That simplifies to that mess? Which simplifies even further into 9 plus 72 is our friend, the 81. Square root of 81 over -4. Okay, so what do you get? This becomes a 9. You guys are good with that? So let's rewrite this. Okay, so all we're doing is we are figuring out who lives in front of the x squared, x, and nothing, right? And we're figuring out over here, that's A, B, and C. And then all we're doing is we're plugging those numbers in. That's it. It's step by step. I wouldn't say it's simple. It's simple in approach. You just need to be very methodical to make sure you don't drop any minus signs like I am doing for you. Okay, and then we're just squaring, adding, multiplying as needed. Okay, nothing fancy yet. All right, so x is equal to -3 plus 9 over -4. X is also equal to -3 minus 9 over -4. Good. And you simplify those to be what? X equals, I have 6 over 4, so that gives me a -3/2. X is -12 over -4, so that gives me a +3. So my roots are -3 over 2, 0, and 3, 0. Good. And it's going to be upside down, and one is on one side and one is on the other. Okay, let's find the vertex while we're here. Okay, so x is equal to -b over 2a. Okay, so -b, b is 3, so -3 all over, oops, sorry about that. And 2a is that. So I have a +3/4. How's that look? Okay. Okay. So then we need the y. So we're going to put that in the original equation. Here, I'll write the original equation one more time. -2x squared plus 3x plus 9. Okay. And now we're going to put x equals 3/4 into that. Okay, so here we go. -2 times 3 over 4. Somebody said, I like racing you to the answer. Perfect. And you can help me fix all my mistakes. -2 times, here, I'm going to leave the 2 there. This is a 9 over 16 plus 9 over 4 plus 9. Okay, so I'm going to add these two fractions. -18 over 16. And I'm going to scale this up. I'm going to multiply top and bottom by 4. So I have a 36 over 16 plus a 9. Okay. All right. Can you tell me what y equals? Can you do that for me? So this mess becomes +18 over 16. So both of these when you put them together. Okay. So y equals 9 plus 1 and 2/8. Which is 10 and, oh wait, I did that wrong, didn't I? 2/16. Sorry about that. I was trying to do it in my head. There you go. So my vertex, x equals 3/4, y equals 10 and 1/8. Okay, how's that look? Did I make any mistakes or am I good? It's a brain confuser. Yes, I would agree with that. All right, how about we do the easy one? What's the y-intercept? Here, I'll slide this down. What's the y-intercept? Y equals 0 plus 0. Yeah, this is the easy one, right? Y-intercept, everyone likes doing this one, is 0, 9. Okay, let's put this monster together. Here we go. And you'll see how small of a monster it really is. Okay. Is it going to be upside down or right side up? Yeah, it's going to be upside down. Okay. And then the first thing we need to do is figure out, let's kind of think about the roots. So I have roots are at, I'll just write them again. I have minus 3/2 and 3. The vertex is at 3/4 and 10 and 1/8. And the y-intercept is at 0, 9. Okay, so I'm going to say the y-intercept's like here. The vertex is just eek over the x. It's like, it's not even at the 1, and then it's 10, so it's up here. So this is 3/4 and 10 and 1/8. This is the vertex. This is the y-intercept. And then the roots are here. So, so you just have to know that this is 0, minus 1.5. And 0, or I'm sorry, not 0. Minus 3/2, got rid. 0 is one root. And the other root is 3, 0. There we go. And now comes the fun part. You get to draw it in with little arrowheads. Whoa, I made the 3 too far out, didn't I? Okay. All right. How's that looking? Doing okay? All right, so let's see what the computer printout shows us. Here's the x-axis and the y-axis. How do we do? It's upside down. The vertex is real close to the y-intercept, and then the x-intercept's minus 1.5 and 3, which is here. That looks good. Oh, I forgot something, didn't I? Yes, I did. Ooh, thank you. Y equals minus 2x squared plus 3x plus 9. Write the original equation. If you turn this in, you will get full credit, 100%. This is worth an A, like an A+, if you did this. Even if your graph was kind of wonky like mine, as long as you label it, most teachers are okay with that. Unless they give you grid paper, then you really have to do it right. Okay. Vertex, I will label all these just for you. 3/4 and 10 and 1/8. Somebody's asking, do you need the tick marks down here? If you are, let's see, here's that one. This is 1, 2, 3. You can. I'm okay if you just put these because you're telling me exactly where they land. So, and you don't have grid paper here, so making them evenly spaced is going to be very, very hard to do. Good. Why is my one so fat? Yeah, mine's a little fat too. That's okay. All right, it's the numbers that we care about the most. Good. So this might be a rocket going up and coming down, or the velocity, or your miles per gallon really tapers off if you floor it at 120 miles an hour. So it could be a lot of things. All right, how are we doing? I thought we would do one more, hang on before you protest. One more where the radicals are not so nice. Just so, this is the last one I'm gonna do, just so you have it as a reference. So if you wanna sit back and just watch, you can, and then you'll have this as a recording, but if you'd like to add this to your notes, you can do it as well. All right, so, because I know in a lot of the labs that I've done them, the radicals are not nice. And so this is kind of I wanted to do this as a bridge problem between the math labs you're gonna be doing, which are super fun, and the ones where, square root of 81 How nice is that, right? Okay, so go ahead and take a sip of water. If you're in my science class tomorrow, I thought we would do the story on the uranium marbles. Don't let me forget about that one. So I do have a funny story for you today. Do you want a Caltech story? Or do you want a story about Aurora in a runaway class? I think we've done most of them. Or Aurora's learning how to teach. So put that in there. Okay. Why do you underline the sign? So that's not an underline. The problem here, let me see if I can grab a sheet that has the quadratic equation. This is not an underline. This says plus or minus. So you'll notice as I'm talking, I don't say underline the plus. I say -3 plus or minus, and then this. So that means you're going to get, that's why we have two answers. This is the plus, this is the minus. Does that help? Okay. All right. Okay. I'm feeling lost, but okay. All right. I'll take it. Okay. So I got your request at the beginning of class for what problems to do. So I think I've been doing most of these. I think I've been hitting most of the ones you've been asking for. Okay. So last problem. And then I've got some funny graphs I want to show you. I shouldn't say funny, mathematically correct graphs. Okay, shuffle. Here we go. Okay, so this is the fourth and final problem. So if you're not taking notes, you're shouting out the answers as I'm going. All right, right off the top of the bat, what's the y-intercept? Good, 0, 2, okay, because we're putting x in. X is equal to 0. That gives us the y-intercept. Good, x is 0. Plug it in. Y is 2. Good. Is it facing up or down? Which one? We look at the A. If A is positive, it's going to be a parabola that is in the up direction. We don't know where it is yet. We have to do some math to figure that out, okay? But we know it's up, and it's not down. Okay, so it's not that one. Good. What else can we tell about this? Can you tell me my A, B, and C? Okay, A is what? Shout it out. Yeah, 3. B is 6. C is 2. Yep. So A, B, and C. These are just the coefficients. Great. Who has the quadratic formula memorized? Ooh, extra point for this one today. X equals... And if you don't have it memorized, you will soon. Negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Good. Plug and chug time. All right, negative b is a minus 6 plus or minus the square root of 6 squared minus 4 times 3 times 2 all over 2a. Okay, already looking inside the radical, I'm seeing this is going to be looking like a minus 6 plus or minus the square root of, this looks like a 36, this is a 24. I already see trouble. Okay. Because the square root of 12 is not a pretty square root. Okay, but that's why I'm doing this problem. So x is equal to minus 6 plus or minus the square root of 12 all over 6. Let's work on the square root of 12. Square root of 12 is 3 times 4. 4 is 2 times 2. So I can take one of the 2's, bring it out. One of the 2's goes away, but I'm still left with that 3. So the square root of 12 equals 2 root 3. Okay, so we're just doing a little work on the square root of 12 here, that's all. Okay, so I can replace square root of 12 with 2 root 3. All right, you want to see me do that? Okay, are we doing good so far? Can I move this? Okay. All right, so here we go. And actually, square roots are really fun when you really get to learn how to use it. So x is equal to minus 6 plus or minus the square root, 2 root, let me do that again. X is equal to minus 6 plus or minus 2 root 3 all over 6. All right, I can divide everybody by 2. I'll get a 3 here, a 3 here, and then that goes away. Let's rewrite it. Minus 3 plus or minus the square root of 3 all over 3. Oh, there's a lot of 3's, aren't there? Okay. So who can tell me what is the value, what is the decimal value to 2 decimal places of the square root of 3? Can you do it on your calculator and tell me? Okay. There we go. I'm seeing it. 1.73. Excellent. Doesn't look like you all got the same answer, so here. You take a 3 and hit the square root. Okay. So 1.73. So this is x equals negative 3, take the top one, plus 1.73 divided by 3. Okay. And x equals negative 3 minus square root of 3, which is 1.73, over 3. Because we have to plot it. We can't just leave it like this. Okay? And then I'm going to get x equals, and then you guys know how to do this. So let me just give you the result. So I have a negative 0.423, and x equals minus 1.58. Those are my roots. Okay. So I have minus 3 minus this. So just make sure you know how to go from here to here. Okay. These are my roots. All right, so I have both roots are negative. Okay, so they're going to be on the other side. And now there's only one more thing to calculate, and that is our vertex. So the vertex looks like this. X equals negative b over 2a. Okay. Now, who can tell me what the vertex is for x and y? Okay, negative b, just stick it in. Okay, for x. Yeah, how easy is that, right? Oh, wait, that should have been a 6. It's so easy, I forgot to write it down. Hang on. Negative 6 over positive 6 gives you a negative 1. All right, now stick that 1 in here. Y equals 3 times a negative 1, which is a 3, plus a 6 times a negative 1. Oh, did I say 3 times a negative 1 squared, which is 3. Here, negative 1 squared. Plus a 6 times a negative 1 not squared, plus 2. Okay, so this is 3 minus 6 plus 2. Gives you a negative 1. So the vertex is at negative 1 comma negative 1. All right. Bonus prize. I want you to graph it for me. I'll put everything here so you can see it. The roots are here. And then show me your graph, and then we'll compare. All right, so the roots are negative 0.4 comma 0 and negative 1.6 comma 0. Vertex is negative 1 comma negative 1. Y-intercept. Okay. Is, 0 comma 2. Good. Go ahead and plot it for me. What do you get? And then we'll compare answers. And that A value was positive. So here, I'll write the original problem. and back up the camera. There we go. Okay. So go ahead and plot that, and then we'll compare answers. And that's it. Somebody's like, is this it? Yes, I promise, this is it. Okay, and then you can show me what you have. A lot of people have it memorized. That's awesome. Good. All right. If you're feeling stuck, I would recommend doing the vertex first. Everything is really, really in here, like between 1 and 2. So you really only need 2 dashes for each one, if you want to put those in. All right, how are we doing? So here's mine. Does yours kind of look like it? Kind of, sort of? It's okay. I know, graphing on blank paper is not easy. Good. And so if you turn this in, if I gave you this original equation and then you turned this work in with your work shown, of course, you would get 100% and a happy face. Good. You'd like to see the computer? Okay, so the computer one looks like this. Let me highlight the X and Y axes. Okay. All right, and you can kind of see it. Oh, let's zoom this guy in. You can kind of see him here. There's your vertex that we calculated, -1, -1. Here are your 2 roots. They took it out to 3 decimal places, but that's okay. And here's your y-intercept. We did it. Yay! So this is not easy. I would agree with you. There's a method, though. Are you seeing how if you just take it step by step? Yeah, there's a way to do these problems. Excellent. Yeah, absolutely. Show me I would love to see your work. Absolutely. All right. I actually have a few things for you. Would you like to see what they are? Would you like to see? Okay. Perfect. All right. So yay. First of all, celebrate. Woohoo! All right. It's okay if you need a little more time with this. This is thick. I think there's like 40 videos in this week's lesson. So take your time with this. All right. I wanted to give you a sneak peek under the hood. So let me show you. Somebody had asked, what if that's a cube? Okay, so this is not for you. In fact, this doesn't even come up for you until calculus. So this is not even an Algebra 2 thing. All right. So if you have a cubic polynomial, meaning you have, let's see, x cubed. Okay, so say we've got 3x cubed plus 6x squared minus 4x plus 5. Right, suppose you got this thing. What does that look like? Okay, you know how we have the quadratic equation, right? Here, I'll write it down here. Y equals x squared plus, 2x plus 3, right? we use negative b plus or minus the square root of b squared minus 4ac all over 2a. That's what we've been doing to find the roots, right? So this is a second degree polynomial. This is a third degree. Sometimes they call it a cubic. Do you want to see what the, quote, quadratic equation formula looks like for this? There's one that exists. Here, let me show it to you. Now, because there's a 3, you're going to have 3 roots. It's so big we don't even write it. Look at this. X equals, so we have A, B, C, and D. So A, B, C, and D, because we have 4 terms. So it's not just A, B, C, D. And this is how they get combined. You have a square root within a square root plus a square root within a square root. All right, so relax. They don't actually give these as problems, especially now that we have computers that do this for us. So here's the one we were working with. So if you're thinking this is a lot to memorize, when I was a student, because we didn't have computers, yeah, this was the headache and a half. Is there a form? Yes, there is for x to the 4th, but there is not for x to the 5th. And it's so big and ugly, no one even likes to talk about it. Do you want to see what the graphs look like? Right? Once you solve this for some numbers, do you want to see what the graphs look like? Look at this. Here you go. Here's one. Look at this graph really carefully. Look at this. This is, how many times does it hit the x-axis? The x-axis will be highlighted here. How many times does it hit it? 3, because it has 3 roots, because it's cubic, because of that x cubed term. It will have 3. If it had x to the 4, it'll hit it 4 times. Do you see that? Because we only had 2, we only had 1, 2, right? And when we did linear, when it was just x equals, it was a straight line, it only hit it once. You kind of see in the pattern here? Isn't that fun? So would I ever ask you to do anything like this? No. But look, they have y-intercepts. We just have 3 roots that pop out. And we have to find the vertex for both. And so there are 2 vertex equations that we use for that. And that's where it gets messy. All right, but I just wanted to kind of show you that to kind of, sometimes it helps to see what's beyond what you're doing to kind of put what you're doing into context. So you're doing this right there. And this is where you can smile and think, whew, right? Crisis averted. All right, yay. How many of you would love to maybe over Christmas break do some just review? Just some fun stuff like, hang on, I don't know, like that. And wait, before you judge it as being just a coloring page for little kids, it actually has word problems. And then based on the word problem, you color it in the color that the secret code at the bottom has. I also have some more code things like this. And these are for if you are comfortable with ratios and proportions. I have another coloring page. This is coloring pages for high schoolers. So if you're interested in this, just to kind of review some of the stuff that we're going to be using when we hit geometry, I can give this to you. So I don't have a video or anything prepared. One of our writers prepared this, but we just didn't get to it. So if you would like a copy of it, send me an email and say, hey, I was in class, can I have the snowman activity packet? And I'll send that to you. And it has answer keys as well. I thought it might be something fun to do. So if you're really excited about that, it's not due, it's not required, it's just in case you want a little something extra. Okay, so I have that available to you as well. All right, so how are we doing? Is it story time? I'm thinking it's story time. Yes? Okay, well, grab your snack. You know the drill here. What story am I telling? Let me see. It looks like a lot of you said your choice. Okay. Why does it matter what side the loop is on? Oh, you mean when we were graphing? That will come up in the roots. So that just tells you where, if you mean the parabola. The parabola will be in which quadrant it lives in, the vertex lives in. Do you want to see one that has an imaginary solution? Maybe that would help. Here, let's go back onto my desk. I'll just draw you a picture. So if I have, say I've got my x and y axis here. X and y. Okay, so if I have, let me draw this in a different color. if I have this is what we've been doing, right? And we've been saying the vertex is here, y-intercept, and the roots, right? What if it doesn't? What if the parabola is here? Does it hit the x-axis? It doesn't. So this is what happens when you have a square root of like maybe -9. You won't have any real roots. So you'll say no real roots. This can also happen over here, right? It doesn't hit the x-axis. So x can never equal anything, right? For y = 0, there's no x value. So no real roots for the green ones, right? And this can happen here. Somebody's asking, can it never hit the y-axis? Yeah, so you can have, this is much more complicated, but you can have the parabola facing the other way, okay? And that's what happens when you flip the x and the y. When you get into it, you'll get into something called hyperbolas. And this is where math really starts to be fun and entertaining. Where, for example, 1 over x, if you were to graph 1 over x right now, so if you were to take this, if x is 1, y is 1, right? There's a point. If x is 2, y is 1/2. If x is, say, 10, maybe out here, y is 1/10. You see how it gets smaller and smaller and smaller, but it will never cross this axis. And also, if x is like, say if it's 1/2, then y is 2. If x is 1/4, 1 over 1/4, right? Then this is 4. So it'll get really, really close, but won't actually cross any of these axes, like this here. That point should be there. Okay, so it will approach it, but never will cross it. You see that? And then the opposite is true because x can never be 0. That's what we're dealing with here. Do you see how if x is 0, the whole thing blows up? So x can't be 0. The other part of this graph looks like this. When you start putting negative numbers in for x, if x is -1, -2, -3, it does the same thing. Okay, and so we have a match set. So it matters where the thing lives because it tells you where the values, where the answers are. These are all answers. Every dot on this line is an answer, is a valid solution. Every dot. And then when you get more complicated, these will become 3-dimensional. You'll have x, y, and z. And trying to graph those is a big pain in the butt. For example, this graph is called the monkey saddle. It's where, see this? That's this part here. But then it's also falling away for us. And if I put a marble here, it will fall, right? So this is an unstable solution. Anyway, we are getting way off topic. So anyway, I hope that doesn't scare you. But there's lots of fun things that you can do with math. A lot of fun things. It's a tool. You just need to know how to use it. Okay, this is, okay, but we have a D now. Oh, for the x cubed, yes, you would have a D term. Yeah. So it matters where the loops are because that tells you where solutions are to the problem. Okay, good. All right, so there you go. So if you have more questions, let me know. We can get, so I'm ignoring all the infinity questions, right? Because infinity, if you can save your questions till you get to calculus, infinity will make, well, I won't say it'll make a whole lot more sense. It'll be less confusing. So just know that infinity is not a number. It's something, you remember I was showing you how the line didn't cross, it just approached it. That's how we deal with infinity. Because if you nail down a number for infinity and say that's the biggest number, you can always add 1, right? And always add 1, always add 1. So we think of things more as a limit as they are approaching something, like what is it doing? Is it dying away? Is it getting crazy? What's happening? Okay, so moving on. Yeah, what a great idea. I would love to, how about an airplane story? Would you like an airplane story? Okay, so for those of you who don't know, I'm a pilot. I've been a pilot since I was 17. I walked into the wrong classroom, and that's how I got my start. I thought it was a class on rocketry. And so I was taking classes at night at a local university, or local college. I was taking math classes and stuff. And so I got my license very early. And so, which means that there is a certain range where as soon as you become a brand new pilot, your insurance rates are really, really high because you're not that great of a pilot. It's like a new driver on the road, right? How great of a driver are 16-year-olds? Not so good, right? And you're like, actually, that stop sign was for you, right? So, but they're learning, right? They're learning. All right, so same thing is for pilots. So, so I was It's a new pilot, and they have what they call the 200-hour mark, which means you need to, it's different than driving cars. So when you are flying, you keep track of how many hours you're actually flying, like in the air. And there's a little meter in the plane that keeps track of the time that the engine runs. So when you could write it in your logbook, you say, oh, I flew for 3.7 hours, right? Okay. So I was in that, excuse me, I was in that 200-hour range of I'm learning a lot. So, okay, so I get in, and here, the story is going to take a second to set up. So I get into my little plane, and I'm a brand new pilot. And I have less than 200 hours, and back, you know the headsets that they wear? Okay, so when I was first learning, we didn't have those. So we had the wire that goes to the airplane, but I had just bought my first headset. I was so excited. And I had used it a few times, and back then, most planes weren't wired for them, and so you had to have this extra little box that you plugged into the airplane. So I had my headset on, and I plugged it into the box, the intercom, and it's this little tiny metal box with a couple of holes, and it plugs into where the mic normally for the plane hooks in. Okay, so I get in, and I put all my equipment in. I'm so excited. I'm going to take myself to lunch. We call it the $100 hamburger runs, where you fly yourself somewhere fun, you have lunch, and you fly back, so you can keep your hours up. So I get in, and the plane does not pass for pre-flight. There's something wrong with the plane. I forget what it is, but there was something a screw was loose, or something wasn't right, or tires weren't inflated right, or something. So I'm like, you know what? This plane doesn't pass. I'm not comfortable flying it. The pilot always has in fact, if you've ever been on a commercial plane, if you look out the window as people are loading, most people miss this, the pilot will be out there. Sometimes it's the co-pilot, will be out there, and they will walk every inch of the airplane to make sure, even if they just came in for a landing, they always pre-flight. So you'll see pilots out there doing that. Not the baggage claim people, the pilot, the actual pilot. Okay, so I'm like, okay, so I unplug my stuff, and I put my headset. You guys haven't heard this one, right? Okay, so I unplug my headset, and I put everything in my bag, and then I go to so I was part of a school, Central Coast Aviation, or Central Coast Flyers, and so they had like 20 airplanes, or 30 airplanes, a lot of airplanes. So I just go to the next one, right? So I go get the keys in the office, and I come back, and I put my stuff in, and I'm really excited. I can't wait right now because I have another friend who's flying in. We're going to meet and have a hamburger or whatever. So I get in, and the plane passes the pre-flight. Okay, I've got the radio. I got my headset on. I've got my radios tuned in, and I'm taxiing, right? So right as we're taxiing, we get to the end of the runway, and we don't go on the runway without permission. And I'm in this area. They call it the run-up area. And this is where you run your engine at full power to make sure that it's going to be okay when you actually hit full power, and it doesn't put and die and all that stuff, right? You check things. So jets do this as they're taxiing. They don't usually run up jets that way, and they have different types of things, right? Okay, so for small planes. So I'm running it up, and the mags, the part of the engine isn't running well. And I'm like, and it's not, you have certain tolerances, and if the engine has an RPM drop that's outside of that tolerance, you're not supposed to fly. So I'm looking, and I'm like, it's clearly outside the tolerance. And I've already taxied. This is my second plane. I'm like, it's not okay to fly, right? Because I'm the one who has to make the decision. And if it's not okay, then, that's my life up there, and I can't just pull over if I have a problem like you can on the freeway. So I taxi back. Okay, so and normally you don't taxi this way, right? So he's got to stop all the people. Normally it's a one-way taxi, right? So he stops, and I go back. And by this time, you tell me, do you think I'm a little rushed? I'm like, right? 2 planes that don't pass. Plane number 3. By this time, I'm starting to get, so we call these things links in the chain. And if you have too many links in the chain, you should just stop, because the odds of something really going wrong are really high. So I'm starting to get a few links in the chain, right? So one of the links, I've got a couple of planes that don't work. Now I'm also got the time crunch. That's another link in the chain. Now my mind is wondering like, oh, I hope this plane's going to be okay too. So I'm starting to get some links in the chain. So, and not a physical chain, just events, right? Okay, so because we're all about with being a pilot, we want to be safe. accident prevention, right? Because we want to be able to fly for a long time. Okay, so I throw my stuff into this plane and literally throw, right? I'm just like, I'm unhooking my wires, my headset, my brand new headset, my intercom, I'm pulling that out, I forgot it, I went back to the other plane, got it back, and I threw it, I got the keys, threw everything in, I'm like, oh, okay, I just got to do this, and I'm starting to get another link in the chain because I'm rushing, which I shouldn't have been doing. Okay, slam the door shut. And I call, and by this time the weather has changed a little bit, so I'm still making sure it's not too windy. Okay, we're good. It passed the pre-flight. We're good. I'm taxiing. Everything's good. I'm doing my run up. I run up the engine, right? And I do all my tests. It's good. I'm feeling good. I'm like, this is going to be a new flight. And remember how I said, having a headset, this was new for me, right? So I was so rushed, I didn't put it on, and I was using the mic like I had been doing. So I was just using the mic and the big speakers in the plane. All right, so I was just using that, and so he's like, okay, 4931 hotel, you are clear to take off. So I'm like, clear to take off, 31 hotel. So I get onto the runway, and it's this dinky little plane, like this, almost the smallest plane you can fly. Like a tuna can with wings. So I get on there, and the runway's huge, right? So I get on the runway, and basically we joke now that this plane had two settings, on and off. So I put the engine to full, right? It's like, it's like, so we start going down the runway, and the second I get off the ground, I start to hear something, like a little bit of a rumble, and I'm like, but I'm like, okay, well, I haven't flown this particular plane. But okay, so I'm listening, and I'm listening to the engine, and I'm taking off, and to be able to fly the plane as we're coming out, and I get out of ground effect, and we're going, and all of a sudden, about 200 feet above the plane, I hear, it sounds like I am inside a giant popcorn machine. It's like, bam, 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 bam. And I'm like, it sounds like things are hitting the plane, and I'm freaking out, right? I'm a new student, and I'm like, bam, 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 bam. And so it did what I should have done, which is I declared an emergency. And I'm like, okay, so, mayday, mayday, I need to land. And so I had run out of runway. So I flew over the end of the threshold at the end of the runway, and there's no more runway, right? So I had to circle back, and I stayed real low. I noticed that when I climbed, it got louder. And if I stayed about the same, it was about the same. Bing, bing, bing. And so it was great. About 3 seconds later, the entire runway is lined with vehicles, emergency vehicles. And I'm flying along the runway, and then I make a turn. It has a happy ending. I'm still here. Look, it's got a happy ending. Don't look so worried. Okay, so I'm flying along, and there's big, they call it the crash team. It's the special ambulances, or not ambulances, fire for airplanes, because airplanes are so much bigger, they need different fire trucks, right? So they're on there, they're aligned, everybody's got their binoculars, they're on me, the tower's talking to me, and they're like, I think there's something not right about our plane. It's like in the back half where the tail is, or the back of the fuselage. And so I fly really close to the tower so they can see if there's something, like, is something obvious? Is it okay for me to land? Did the landing gear snap off? Like, I don't know. Like, I can't see, right? So I go by, and they're looking, and they're like, no, I think she's okay to land. So I get on the ground. I land. Everybody converges on me. The owner of the airplane walks over, opens my door. Everybody's standing on the runway, right? Because they have to shut down the airport, which is not a big airport. It's a small airport. And he walks over, opens the door, hands me my intercom, which is dangling by its cord outside the airplane, and hands it to me. So what was banging against the side? Which is not good for airplanes, by the way. A big, heavy metal box banging on the side of the airplane. All right, do you see how this was entirely my fault? Everybody was happy, I was safe. They were like, I think it was her seatbelt. She didn't have her seatbelt. I'm like, no, my seatbelt is on. Like, it is not a seatbelt. I wasn't using my headset, and I wasn't using the intercom that I had brought to plug in because I was rushed. Remember the links in the chain? Because I was rushed, I was in a hurry. When I slammed the door, the intercom was still hanging outside, but the cord was inside. So as I took off, the thing started banging against the side. Fortunately, the owner was actually also an auto mechanic. So he was able to get the dents out, made the plane airworthy again. I got a big old lesson in links in the chain. And I got to tell you, from that, this is how we learn. That's why those first 200 hours are really, really important, that you learn as much as you possibly can. Bringing this full circle to where you are now, you guys are in the first 200 hours of algebra and of math. And so I want to make sure that you guys don't have any experiences quite like I did, as hair-raising as I did. So when you're doing your math problems, things can go horribly wrong, right? And you're like, just take the piece of paper, just start it over. Piece of paper is cheap. Start it over, write really easy, write nice and big. If you're rushed, you're going to make mistakes. If you're writing small, you're going to make mistakes. Keep it simple, keep it organized. There's a structure, follow it, and you'll be able to, it will make sense. All right, and I am okay, I'm safe, everybody was fine. The crash team had a big old laugh. Everybody, the tower had a big old laugh. And yes, so yay! Did I learn something? Yes, of course I did. Make sure your intercom is plugged in before you take off. All right, so there you go. What do you think about my airplane story? Hair raising. Don't tell a story that's scary again. Oh, I hope it wasn't too scary. Look, I'm here, right? I'm here. But yes, this is why we have procedures for things. This is why we have a lot of training. Yeah, and actually once you're a pilot, they call it, when you get your pilot's license, they will tell you it's a license to learn. It's not because you know everything. And this is, I don't know, this is like one of the things I hear from parents a lot, especially homeschool parents. They'll say, okay, I just need to know what is the curriculum that'll teach my kid everything. And that's the wrong question. The question is, what is it that what tools can I arm my kid with so that no matter what else comes at them, they'll be able to figure it out? Do you see how that's different? I don't want you guys to memorize everything and just be able to handle everything. I want to give you the tools so you have enough confidence in what you're doing and the tools you need so you know what to do once you get there. You're going to approach things and see things and math things we don't even have in textbooks yet. Nobody's even discovered them yet. So there's going to be things coming at you that we can't prepare you for, but I can do my best in making sure you're happy, confident, have tools so you can get out there and you're curious about the world and you get out there and you explore it and you have the tools you need, confidence to start chipping away at a solution. That's my goal for you. And that's what we do in our program. And this was the longest class ever. Okay, so we need to wrap things up. Okay, so yeah, was I embarrassed? Maybe a little bit, but I was grateful. I think that was probably the number one thing, that I was on the ground, I was alive, and that it really wasn't, it was my fault. And it was something I could learn from. So I didn't feel embarrassed about that at all because I knew I didn't have to be a big shot and have to know everything. I was like, you know what? I'm learning. Lesson learned. Good. Moving forward. I'm so sorry. I'll pay for the damages. I'll take care of it. And let's just keep moving, right? It's just how it goes. Yeah. All right. So if you have any other questions, let me know. We will do, let's do our giveaway during the math party. I agree. And if you have any other questions, let me know so I can help answer those. You have a lot of fun things coming your way this week. You have, for example, we are on session week number 7. I want you to finish the quadratics workbook, okay? And so it does have step-by-step instructions. Remember, this workbook, I am doing, we didn't have time last year when I made the videos on how to solve all the pages. So it's the handwritten copy. But your workbook looks different. It's just because it's typed up. Okay, but the problems are exactly the same. So just know the format's a little different. We have a lot of different activities that you get to do. And there's a clue game in there, and there's scavenger hunt, and the math labs are really, really cool. They will start to show you, so one of them is gravity and escape speed. One of them is the Juno spacecraft. There's a rocket launch. Pluto's fifth moon, if you're really like learning about different objects that are in space, that's out there. And Alpha Centauri B, so Beta B, is a star that's out there really, really bright. We have some data for it, and you're going to be doing some algebra on. And so we have a lot of really cool different projects that we get to do. All right, and so here's another picture of that one for the spacecraft. Yep, and you see some square roots in there. You see some exponents. Yep, that is algebra all over the place. And we're doing some data with rocket launches and all kinds of fun stuff. So yes, so we're going to go do those step by step. All right, I will see you for the party on Thursday. So Thursday, you're going to have Doug in the morning, party in the afternoon. Can you handle 2 things in one day? I hope so. So make sure you make the most use out of this, and then you guys have a break, and we will see you, I think it's the second week of January when we start back up. The calendar is already published, and you can check that out as well. All right, I will see you soon. Bye-bye, everybody.